Let's start by summarizing the desmos lab you were working on. When we have a parabola, we've seen this already, that the roots correspond to the factored form of the quadratic equation. As we carry that through to a cubic function, if we have 3 roots, we see that each one of those roots is going to correspond to a factor where, notice, for example, if I were to let x equal -2 in this equation, I would get 0 times some numbers. So the result would be 0. So I get the output -2 comma 0. So the factor corresponds with the root that makes this factor 0. Right? So that's why it's x plus 2, because x plus 2 will mean x equals -2 will be 0. As we move ahead and think about 2 roots, I'm going to skip this slide for a second. It is possible to have a cubic with 2 roots, but the question is, how do we modify it to match? So a first natural guess would be to have that factor, and we certainly need x minus 2. But of course, if we submit that, we see it's quadratic, right? Because of course we only have 2 x's, so I only have an x squared here. I don't have an x cubed. And I can't go adding any additional factors because then I'll have an extra root, right? So like if I put an x minus 1 here, now I've introduced a root at 1. But you know, now that I look at it, this is really similar in shape, right? Like I wish I could almost like slide this 1 closer to 2. Like I might think about, okay, what if I made this like 1.99, right? Then that's going to look really close to the actual polynomial, right? It sort of felt like I cheated though, right? Because the computer isn't really graphing, it's not distinguishing 1.99 from 2. So what I've really graphed, if I don't want to introduce a new root, right? Because this one has a root at 1.99. If I don't want to introduce a new root, I really just need to multiply by x minus 2 again, right? Then I'm really getting this repeated root here. Okay, and by the way, the more convenient way to write this would be to write it with an exponent. Okay, so there's our polynomial, and what we want to notice from this is this sort of repeated root behavior will correspond to a factor that has a sort of a repeated power. Okay, and so we're going to talk more about that next.